In this lecture, we're going to be talking about, as the title says, classifying triangles. And it should be a pretty straightforward idea. It's not the end of the world difficult. And a lot of the stuff is going to be stuff that we probably come into this class knowing, although some of the definitions that you might think you know might have to be tweaked just a little, and that's okay. We're also going to hit a couple new vocab words at the end, and then the last thing is going to be talking about some of the ideas that you got to keep in mind as you're communicating your understanding. Right, so first way we can classify triangles is by their sides. And if you have a triangle in which all the sides are equal, you have what's called an equilateral triangle. And if a triangle is equilateral, then it has three congruent sides. That one's pretty straightforward, pretty basic. You do have to have some sort of indication that these three sides are the same length, are congruent, whether that be marks like that or actual side lengths. You have to have some communication that they are all the same length. But if they are, they're what's called equilateral. This next one is one that you probably have an understanding of, but maybe not a perfect understanding of. And that's the isosceles triangle. And there's just two words that get added to this and that make it the more complete definition, and that's the at least. If a triangle is isosceles, then it has at least two congruent sides. A lot of us come in knowing or thinking this is the definition, what you have here on the screen. And it is an isosceles triangle if you have two congruent sides, but if you have at least two congruent sides, it's isosceles. So technically every equilateral triangle is also isosceles. But more often than not, when we're talking about isosceles, it is the version that has two congruent sides. And then a couple of vocab terms with this triangle in particular. This angle here that's formed by the congruent sides is called the vertex angle, right? If it's the angle formed by the congruent sides, it's the vertex angle. I'm going to trust that you can probably write that down without me writing it down. And then the other angles, the non-vertex angles, are called the base angles. Base does not mean bottom. It does, as you can see in this particular picture, it's not sitting on those angles. Those angles are not on the bottom of anything. They are the base angles because they're not the vertex angles. So base doesn't necessarily mean bottom. And then lastly, we have scalene triangle. If a triangle is scalene, it has no congruent sides, and that can be communicated a couple different ways. You can look at it like it is right now because there are no congruent marks, so you can't assume that any sides are congruent, or you can have three different congruent marks, 1, 2, and 3, and the fact that they're different is all that matters. There's no it does not communicate any level of ratio between the sides. It's just three different side lengths. But either no marks at all or three different marks will communicate scalene. So those are the three ways you can classify triangles by their sides, which are equilateral, isosceles, and triangle. And scalene. Angle, a lot of them these are all going to be phrases we know and we're used to. If we have all acute angles, then you have an acute triangle. So if a triangle is acute, then it has three acute angles. All of them are acute. All of them are less than 90. And you don't need the measurements to do this, to have this in place, because we can say that these are 75 and 75 and 75, so that we're going to put 30 up here, right? Sorry, that's a little sloppy. I'll see if I can't make that a little neater next time. But we can look at an angle and say it's acute. We just can't look at an angle and say it's a particular angle measure. So this is a situation where, yeah, we've got an acute triangle because all of them are less than 90. And if you're sketching it, including the angles is a great way to compensate for any poorly or questionable angles, right? Sometimes I can't help but draw a 90-degree angle. So if you put the angle measures in there that are less than 90, then it's fine. That will help. If we have an acute triangle, stands to reason that we also have an obtuse triangle, except if a triangle is obtuse, then it has exactly one obtuse angle. And you're going to want, again, this, even as it is right now with no additional marks on it, you can say, you can work under the assumption that this is an obtuse triangle because clearly this angle is more than 90 degrees. If you don't feel comfortable with that, put an angle measure in there that's more than 90, and there you have it. That's an obtuse triangle. And then, last but not least, we've done acute, we've done obtuse, so right triangle. Now, in the same manner that obtuse triangles only have exactly one obtuse angle, right triangles have exactly one right angle rather, and you have to communicate that. You have to put that mark in there if you want to appropriately communicate that idea. Right? So by their angles, we can call them acute, obtuse, or right. One of the things that we're going to do in a future activity is going to find out, can we combine multiple things at once? Right? A couple new terms here. Median of a triangle. We're not talking about the median from mean, median, and mode. If you remember that from any kind of elementary stats work, median is a segment that connects a vertex to the midpoint of the opposite side. So LO is the median here. Segment LO is a median because we know O is the midpoint because of these marks. Again, when we're talking about sketching things in an effort to communicate your understanding, those marks are really important, and you can't overlook those. You have to put those in it if you want to communicate that I know O should be a midpoint. Put those marks in there, and then you'll have it. Right? Any triangle is going to have 3 medians because they have 3 vertices and 3 midpoints of sides, so that's they're not always included in every picture like this one. I don't want to clutter up the drawing. But everyone has 3, and you have to have those congruence marks in there. Those are not, oh boy, I'll try to remember. I'm like, no, that's how you are going to communicate that's a median. Without those, I'm not convinced you are understanding what a median is. That it's as straightforward as that. Okay? And then the other idea is an altitude or a height. It's the same. They're synonyms. So if a segment is an altitude, if a segment of an altitude isn't an altitude of a triangle, I'll cross that is off. I don't know what that's doing. And I don't know what that is. I apologize. I should have proofed this a little more. I'll go back a little and fix that. Then it connects a vertex to a line containing the opposite side at a 90-degree angle. Right? Just like before, there's 3 altitudes because there are 3 vertices. Right? But an altitude can be inside, outside, or aside of a shape. Right? If you take a look at this one, they call it H because it's the same as the height. Right? There's no way that you're going to be able to connect this vertex here to this base over here and have it be a 90-degree angle. It just isn't happening. So they include this, they call it an auxiliary line to extend that base out such that you could drop you could drop a perpendicular segment straight down. Right? That's what makes that an altitude, and it's outside the shape. This one here on the down below is more, I think what a lot of people think of it is it connects here, a vertex, straight down to this side at a 90-degree angle. And again, when you're trying to communicate, yeah, I know what an altitude is, you better be including a 90-degree mark if you want that truly to be communicated, right? And it can be the shape itself. If we're talking about a right triangle, right, a side of that triangle is a perpendicular from a vertex, right? So a side can be an altitude in the case of a right triangle. Okay? So just some things to remember as we're going through here. if we're looking at this one here, so you're going to be able to mix and match to some degree, right? You're going to be able to mix and match to some degree. And when it says label and sketch and properly label as completely as possible, whatever it is that they're asking, or if you're trying to classify it as completely as possible, you might need to make a statement about angles and about sides. Sometimes you're not able to, right? But if you can do both, right? And that's one of the things that the next activity is gonna get some practice on. Congruence marks, whether they be lengths or angles, are crucially important to classifying and sketching triangles. When you're trying to communicate that understanding, you have to put all the right things in there. If you don't, then doubt is going to be raised in your teacher's mind. All right, so make sure you have all those marks that you should to communicate whatever it is that you're trying to communicate. And your sketches don't have to be perfect, but you should try to make it close. For instance, I'll do this one up here. If you do this, and if you were asked, okay, sketch me a right triangle, and you draw me that, and then you put something that looks like a 90-degree mark, you could do better than that. So take some time to when it says sketch, you don't have to break out the ruler and the protractor and all that, but you should at least try as well as to get what you're doing as best you can. Okay, so those are how we classify triangles. A couple new vocab terms and some really important things to remember if you want to communicate your understanding as best you possibly can. You'll have plenty of time and practice to go over this. So if you have any questions, please reach out. Hope this helped.